Assalamualaikum warahmatullahi wabarakatuh. I am Ahmad ALIAS.
Objective: design a monitoring structure to manage the energy for the usage house as we can limit power usage that exceed 5 kilowatt and create intelligent comfort home to be live in. Next, to oversee intelligent home that using renewable source refer to solar energy of energy consumption.
Assalamualaikum warahmatullahi wabarakatuh. My name is IZAZAYA with HANAFI. Today I will explain to you a report summary for our group project. Okay, first I will explain to you about the power scheduling. Okay, we make power scheduling using PVCs and made some we made it and made some limitation in it which is geographical parameter. Limited number of appliances can be used and do not meet the requirement of our supervisor, which is need to use one dashboard. And then we already know how to use Simulink and make some suitable algorithm and run it in Simulink, which is we have found 4 algorithms and succeed to run one of them. Okay, next I will explain to you about the purpose methodology for power scheduling. Okay, this is the diagram that we use, which is as you see the solar panel, controller, inverter, and battery, and that's the appliances. And next, for the current stage, first, okay, with this diagram that we manage to produce from the PVCs, which is we have some VMS solar panel, controller, inverter, battery, and the appliances. And next, we have to set the geographic parameter, which is we use Abu Dhabi because this is the only place that have that at the PVCs. So we have to put the information that we made from the table, which is the prices that we use, the power that we use, and that the daily use, the how many hours that we use per day for the prices, and the number of prices that we use. So we managed to get to know, okay, for the green, if this orange color show that this time will the prices will on. So we produce the daily global consumption graph. So the upgraded work from the submitted proposal is first, preliminary, we do not really know how to use MATLAB, Simulink that can relate some equation, but for the mid, we gain some knowledge for the MATLAB, Simulink, and very enough to apply it. Next, we don't have to have the prototype system algorithm, but now we have found it. And then we don't get the idea how to make power scaling using PVCs. Now we successfully do the power scaling using PVCs. And last but not least, we only use 5 pieces for power distribution system, but for midterm we use 9 pieces for command management system. And so the issues and how to solve it, which is first issue that I face is we do not know how to interface with PVCs and Simulink. First, and then limited geographical parameter, system that they do not control using one dashboard, and limited type of appliances that can be used. To solve this problem for the system do not control using dashboard and limited appliances, I think I have to make some research that instead of using PVCs, I think we have to change to other software. And then for the geographical parameter, we have to put the new geographical parameter that focus on Dubai. And then for the limited prices, then we have to discover more about PVCs, especially how to interface it with MATLAB. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zubair Ahmad Hashim, and let's proceed to the next section. And for the next session, I'm going to explain some issues like about our current stage and encounter issues and the solution that we have suggested to encounter the problem that we have faced. These are the formula that we have found, and we are trying to use the formula, and we're going to convert it into block diagrams using MATLAB Simulink. Next, we take a look at these two graphs. These two graphs is actually the IV and PV characteristic of the photovoltaic panel system. And from these two graphs is actually our expected result that should be get after we combine all the 4 blocks diagram from the 4 formulas before. Next, we take a look at this figure. This figure is actually the blocks diagram from the first formula of the 4 formulas from before. The first formula actually tell us how many sunlight can be captured from the photovoltaic panels and converted it into the electrical currents. Eventually, I managed to complete only one formula from the 4 formulas. If I want to complete all the formulas, I have to combine all of it, and to combine all of it, it is very complicated since we have to combine 1 to 2, 2 to 3, and 3 to 4 of the all 4 formulas. And if we want to include the result into our power scheduling algorithm, we also need to use MATLAB simulating, which is going to make it more complicated. So in the future, we think that we will try harder to complete the formulas with our knowledge and understanding on MATLAB simulating. We will try to get some guidance and tips from internet. If we still don't get the result, we might have to change the software. And if we change the software, we might have to change all the methods that we have used to get the power scheduling algorithm. That is all for me. Thank you.
My name is Ahmad SHAUQI, and I will present about temperature for the part of comfort control. For proposed methodology, as we want to maintain the temperature of house is refreshing and conducive, we decided to set the house temperature at 22 degrees Celsius. And for example, if the temperature reading is at 25 degrees Celsius or more than that, the system will regulate by switch on the fan to regulate the temperature of house. And next, when temperature reading is 20 degree and below, we will switch on heater so that the temperature of surrounding become warmer. We help the system to regulate the temperature of surrounding. We use LM35 that will help the system to regulate the temperature of surrounding comfortable for people to live in as it control the fans will or not. And the reading of temperature will be read by the LCD. So, and for software, we use Arduino Uno to program the control system. And let's proceed to the current stage. For the current stage, all LM35 sensor has been assembled in the circuit, and the connection between hardware and software are well connected. The temperature sensor for 3 rooms has been assembled with suitable coding. And LCD will display the reading as shown in figure 5. And you can see the figure 5 in the report. So next, we have decided to set up different temperature for system regulation to all 3 different rooms according to its suitability and needed. And for example, we try to reduce the setup temperature for system regulation to lower than previous one for the section of bigger room due to its wider space so that less energy consumed. And it can be said that less energy consumed if the fan start to rotate at 24 degrees Celsius rather than 25. It can help to maintain the surrounding temperature at 20 degrees Celsius and less energy will be consumed.
Okay, for methodology, we decided to prepare about 5 sensor LDR for 5 section. Okay, this is a situation light intensity more less than 300, it will activate LED. If it more 300, it will deactivate LED. Current stage, light comfort control. We provide 5 sensor LDR for 5 section of house, and next we coding the Arduino and LCD to make sure we can read the reading of light intensity. This result how we create coding and test LDR comfort control. Of this Gantt chart, our group do really follow the Gantt chart and the schedule given by the lecturer. Okay, for upgraded work from previous preliminary work, okay, for comfort control, previous session we just using blink to active the circuit. Okay, for midterm we using sensor, ultrasonic sensor for active the circuit. Now for next we provide only one sensor LDR and one LM35 for house for previous comfort control work. For midterm we using 5 sensor for LMDR and 3 sensor LM35. And next, for comfort control, air condition and fan was used to control hot temperature in Dubai. Also, for midterm, beside air condition, we use heater to encounter cold temperature in Dubai. Next, for encounter issues, need another system which can enhance our comfort control system and make it smarter. Next, using Arduino Uno, which not have enough pin to connect between all a sensor. Next, face limitation of idea for increase the temperature if sudden drop of surrounding temperature occur. Next, suggested solution, comfort control using ultrasonic as a switch for LM and LDR sensor. Next, change to Arduino Mega 2560. Okay, last, future work. Interaction between temperature and light comfort control, the assembling of circuit will be done on Arduino Mega. Next, using sensor, ultrasonic sensor perform as switch to LDR and LM35 sensor, create system which can control brightness and speed of fan or air conditioner.